Okay, today we're going to demonstrate cavitation on a boiler feed pump. This is in a pulverized coal plant. We have two feed pumps. Each is rated for 60% capacity. Usually we hit about 290 megawatts. We'll start the second feed pump. Overview of the system. Have a deaerator. It's about 80 feet above the feed pump suction, and it's under about 20 pounds pressure. The water feeds the booster pump. Right now it's at 226 degrees. This pump setup has a steam turbine between two pumps. There's a booster pump through a gearbox on one end. The water from here goes through feed water heater 5, which raises the temperature about 300 degrees right now. Then it goes to feed water heater 6, comes out there about 363. So we start at 226 degrees and end up at 363 for the main feed pump suction. This is the main feed pump. It has an extra booster stage in there for running the superheat sprays. It has a stuffing box, cold injection water stuffing box on the feed pump. So you use seal water to seal the shafts on the feed pump. It has recirc valves. The main feed pump recircs at 740,000 pounds an hour, which is about 1,480 gallons a minute. The booster pump, this recircs at 1,150,000 pounds an hour, and that's about 2,300 gallons a minute. This is the lube oil screen for the feed pump. As you can see, we have a steam turbine. This uses steam off the IP exhaust. That'd be steam going to the low pressure turbines. Runs about 150 pounds. There's a gear reducer for the booster pump. The booster pump runs around 3,600 RPM. 502 psi and can pump 5,100 gallons a minute. The main feed pump, it runs 2840 psi G, can pump about 3,900 gallons a minute, and its speed runs 5,825 RPM. It has a turning gear on it, thrust bearings. Have your thrust bearing positions. I think this one, at 18 mils movement in the shaft will trip it. There's pretty tight clearances in the turbine. It has a basic lube oil system on it. You have a vapor extractor. This removes any gases or vapors out of the lube oil tank and provides a slight negative pressure on the bearings so you're not dumping oil mist out. And here the air should slightly flow in, keep oil mist from making a mess and creating a fire hazard. Before you start a pump, you should check all your equipment, make sure it's in auto. This has two AC driven pumps and one DC backup pump. As you can see, this one is not in auto. So before you start a piece of equipment, you should make sure everything's in auto. This oil temperature is about 70 degrees, which is fine. Too cold, the turbine oil is worse than too hot oil. Gets down to 50 degrees, you can get a lot of oil whip in the bearings. When you shut a turbine down, you want to keep the lube oil on until the shaft temperature cools down below where you'll damage the babbitt and the bearings. Okay, it's in turning gear. Turning gear is running in auto. These small turbines, it isn't too critical. The large ones, you have to have in gear a long time to get the bow out of the shaft. To start this, we have a page where we can set the speed for bringing it up. This turbine has two separate steam supplies to it. Right, you have the low pressure, which is coming off the IP exhaust steam. And once these valves go 100% open, then it goes over to the high pressure steam valves. This comes off the main steam header. So it'll run on main steam if there's not enough steam for the low pressure. So it's a bumpless transfer between the two steam supplies. We'll go to the control mode. Right now we want to put the speed setter in. This will run the speed automatically. This here's a normal control for the feed pump. We have the control set point. We have 800 RPMs a minute increase in it right now. We can't take the target until we latch the turbine. Okay, we're going to latch. What this does is resets all the safety circuits. It's kind of like an 86 relay on a generator. You want it to trip and you don't want it to reset without you manually resetting it. The latch comes from an old steam turbine where you had a trip latch and there's a bolt on the shaft at high speed. It'd fly out, hit the latch, release it, dump the valve, drop oil pressure and shut down the turbine. So when I latch this, we're just resetting the safety circuits on it. So at this point, all the safety circuits, all shut down, have been reset. We have to open the block valves to it. Both the high pressure and low pressure steam. Okay, we should be able to type in our target. We're going to run to 2,900 RPM on it. That's right below the cavitation point. We'll go back to our lube oil screen. We can watch vibrations and any problems on it. It's usually a good idea to have somebody stand by one of these when you start, just if there's anything going wrong with it. On these graphs, we've listed the booster pump flow. We've got the main feed pump flow, we got the speed, and then we've put on various vibrations. It's kind of a good idea to track vibrations and different parameters you're starting up equipment. These pumps got started and stopped quite a lot because once you come below 270 megawatts, you had to take a feed pump off. And if you got above 290, you'd put another feed pump on. The actual size of the feed pump turbine was fairly small. They're pretty durable little turbines. I'd say it put about 10,000 horsepower. We've had about 150 pound steams off the IP turbine and then exhausted down to the main condenser. So it had gland steam on it. I'd say the main feed pump, there's a trip at 3,400 PSI on it. If the pressure got that high, protect piping. Most of the water went to the boiler. Then there's a separate booster stage that ran the higher pressure for the sprays, for the superheater sprays. Usually the problem with this pump, this runs a little slower speed than the main feed pump, so it will outpump it at certain ranges. There's certain flow ranges where you wouldn't run this thing at. It just starves your main pump and will start cavitating. When the pump cavitates, it'll cause a lot of piping movement and cause a lot of damage. So you want to avoid cavitation on pumps. You can also get cavitation from overdriving a pump. It's pumping out more water than it can on the curve. Starts making a really low pressure on the suction. You get small bubbles that'll collapse and make a lot of noise and do damage. Actually start eroding metal. Ways to prevent cavitation: you can keep higher suction pressure, limit the throttle pressure. There's some changes to the impellers that can be made. Usually cavitation is pretty detrimental to pumps. And you also have to have minimum flow on these things, otherwise they'll produce a lot of heat and do damage. That's why we have the recirc valves. We're coming up pretty good on speed, 2600 RPM. See, temperatures are starting to climb on the bearings. We're starting to get some vibrations. I say thrust position is critical on these things. You can damage them. Sometimes you get excess thrust on the turbines. The clearances are fairly tight. I'm thinking this one trips at 18 thousandths, and I don't know, 22, 24, it could actually start hitting stuff inside. So there's really tight clearances in these. Okay, we've reached our speed. We're going to try to adjust the speed manually. Okay, as you can see, it's not going. We still have it in control mode. So we got to put it back into remote. Now we'll have control of it. Over here we have our steam valve position. These controllers you have to highlight to get control, which is a good safety feature. You can't just click on the wrong one. Okay, we're going to start bringing the RPM up. As you can see in our graph over here, this is our speed of the turbine. The feed pump speed is starting to come up. The green is the booster pump flow, and the blue here is the main feed pump flow. On the feed water screen, you can see our recirc valves full open on the booster. It's open on the main feed pump. Kind of nice about the graphics, you can bring the controllers up different places on different graphs. You can move them, you can resize them. So that's kind of a handy feature. We have both feed pumps here. A and B are both on this controller. Right now, normally you'd be running through this range real fast because you're going to get the cavitation problems. But for demonstration purposes, we're going to go slow and see if we can get this thing to cavitate. Usually it does a pretty good job of it. So you can see the booster flow is picking up. Turbine speed's picking up. Recirc valves are still open. Definitely want to avoid cavitation on pumps, especially a pump this size. You can do a lot of damage. You got a lot of horsepower and a lot of force. Okay, pump speed's coming up pretty good. Move the controller out of the way and see what our feed's doing. So right now it's in 1150. It should be getting ready to start closing the valve. Give me kind of a critical range for it. It should start swinging here. Say this is something you really don't want to do to a pump, but you can see it's starting to move a little bit. It's starting to bounce around. Sometimes emergency shutdowns, when these recirc valves don't work correctly, it can move piping quite a lot. Okay, you can see we're starting to cavitate it. So you always want to make sure your recircs are in auto and they're working when you're starting up a large pump. Okay, this is what you want to avoid right here. We're showing cavitation on the main feed pump. It's creating a lot of force on the pump and the turbine shafting, not to mention the water piping. And your feed water heater. It goes from here, it goes to feed water heater 7, then it goes up to the economizer in the boiler. So as you can see, we've got a pretty good swing. This graph shows both feed pumps. We got the total feed water flow here. We have a feed pump, and we got the B pump we just started here. And here's the drum level. So this is swinging pretty good. This is why you drive through this range fairly quickly, to keep the pump from cavitating and swinging. You see we're getting the booster pump swinging too now a little bit. So this is something you don't ever really want to see in a power plant and with your feed pump. If you get this situation, you got to drive the flow up quick or trip it. But you don't want to hang here. It will. You can tear up thrust bearings and do some other damage to the equipment. Right now I'm just kind of curious how far it's going to go. Seems to be the point, it's getting worse and worse as it goes. So to get out of this situation, you need to get out of this flow range. On this screen we have the recirc on the booster pumps open and also the recirc on the main pump. The A pump is running about 5,000 RPM. The B pump's running 4,100. See, we're getting. So we're going to get out of the cavitation. Now we're going to go ahead and start driving this pump up. This should run up pretty fast. You just hold down the manual button and drive it up quick to get out of here. Recirc valves will close. We'll get this running, then we'll bring the other pump down, and we'll throw them back into mid auto. You don't ever want to get to the point where both these things are running in manual. Just have your feed pumps and stuff in automatic. I'm going to drive him down a little lower. Kind of line up the speeds on them so they don't jump too much. This boiler uses the feed pump speed to control drum level. I'll jump a little bit. There's no level control valves on this. That's all done with feed pump speed. So the feed pumps will line out. We didn't swing the drum too much. Right now we're 2 inches high. You can see from this screen what happened. We moved it a little bit radical for purpose of this video. See your drum levels coming up. Feed pumps are swinging around. We did get rid of the cavitation on the B feed pump, so they're lining out on it. And this is cavitation on a feed pump, which you never really want to see. Got a few alarms coming in. Feed water block decrease. Drum levels going a little bit high. Do a good job with this. You shouldn't see your drum level swing at all. It should be within an inch at most. But it makes a better video if things move around a little bit. Anyhow, that's feed pump cavitation. Any pump cavitation is detrimental to the equipment. You have a pump that's cavitating, you need to figure out what is going wrong with it and correct the problem. It could just be trying to pump too much water with the pump. This one here is in a bad range for the pump. Design specs, usually at 2900 will drive up real fast to around 4800. Today we just went a little slow through here to demonstrate this. Anyhow, that's feed pump cavitation. Don't do this in real life. Have a good day.